So hi everyone, today I'm just gonna give a very short presentation on Atlas Photometry, which is what some members of our AGN group here at ANU use. So Atlas stands for the Asteroid Terrestrial Impact Last Alert System, and it's a system designed to detect potentially dangerous near-Earth objects. It consists of 4 telescopes, 2 in the Northern Hemisphere and 2 in the Southern Hemisphere, and it detects those objects by surveying the sky with a cadence of 1 to 2 days. So after taking the pictures, they subtract a reference image, which we will refer to as a wallpaper, from the target image. And this difference image is passed through an algorithm where they detect variable objects and moving objects. So if you're interested in how all of this works, there's a lot more details in this paper, Torin et al. 2018. So why do we use Atlas? Atlas has really good cadence. It has a 1-day cadence in the more equatorial regions and 2 days in polar regions, and it visits each field 4 times per night. And it also has years of data available. It observes in 2 filters, the orange and the cyan, though the cyan band is only observed during the lunar dark phase. And the 5 sigma limiting magnitude of Atlas is 19.7. Now I'm just going to briefly show how we get data from the Atlas server. It's pretty accessible. So this is a website. Before you get any light curves, you need to register an account and log in. And you can request the light curves from the queue page here, which is shown here. So Christoph has actually shown some Atlas light curves before, but if you remember it, you might have seen the difference light curves where it's centered at 0 and the absolute light curve, which I will refer to as reduced light curves here because it's the term used by the website. So from Atlas, you can request the difference light curves or the absolute or reduced light curves. And the output page gives you what columns the data files have. I also want to bring attention to the common sense filters recommended by the website. This is picked from the FAQ page. It's pretty useful for filtering out bad data. And if you're interested in to request like a larger number of light curves, which I do for like several hundred light curves, there's Python code in the API guide page, which is very useful that you can use. So now I'm just going to talk about a few things that our group has noticed and you should also look out for if you are using Atlas data. So first of all, the wallpaper, which is the reference image that's subtracted from the input images to get a difference image. So Atlas has changed their wallpaper, and one of the major changes is that MJD 58882. And so this would affect the difference light curves. Our group has noticed that in some objects around this time, which I've dotted down with the green dotted line here, there's a discontinuity before and after this wallpaper change, which we refer to as a wallpaper jump. And this is shown in the top plot. And the bottom plot, oh, sorry, okay. Okay, and then in the bottom plot, this is just a by-eye correction done to show you what the light curve would look like if there was no wallpaper jump. The website kind of implies that it only affects southern objects, but we've also seen this in the northern objects as well. So maybe some of you might be thinking, okay, if there's this issue in the difference light curves, why not use the reduced light curves instead? So because Atlas is designed to be used on, the Atlas module is designed to be used on different images. So there are some issues when you use request light curves in reduced mode, which is one example here in crowded fields. I'm showing 2 objects here. On the left is J2157, a relatively isolated quasar, and on the right is another quasar, but with a bright neighbor near it. So, and I've also plotted the reduced light curves for the 2 objects, and you can see that with a bright neighbor, the reduced light curves look a lot noisier. So this is something to look out for. And in this case, I would definitely recommend using the difference light curves instead. And one more thing is that you probably, depending on your usage, you might want to clean the light curve further other than the common sense filters that I've mentioned before. This is just an example that I'm showing here where I do a reduced chi-square cutoff of less than 5, taking the median in a 7-day stack and only using nights with 4 visits. This is because Atlas is designed to visit each field 4 times per night. And if there's actually only 3 visits in the data files, this could be an indication of bad weather. So we remove those data points just to be safe. And the last thing is that we've noticed for extended sources, for example, NGC 5548, we find that the PSF fit has a higher reduced chi-squared, but we don't see the noisy signatures that I've shown 2 slides ago in the light curves. So this is something that you might want to pay attention to if you are, for example, using the reduced chi-squared as a cutoff for cleaning the light curves. So that's all for me. This is a very short presentation. Let me know if you have any questions. Thank you.